All right. Um. So this week, um,
I want to take it
it
off.
said for us to do both part 1 and part 2, right?
Oh, it's drying off.
I think so, yeah.
Okay.
I know I did mine, but
Yeah, I did
I'm an
too.
overachiever, I think. So,
What's that? I'm sorry, I missed that.
So this week the instructions were to do part 1 and part 2 by ourselves.
Uh-huh.
So were you able to do part 2 also?
I did most of it, but I didn't get to 12 and 13.
Okay. Well, we could do those two and then take the quiz together.
Okay.
Cool. I'll try to invite Elena again to see if she can get on.
do we have any questions about any of the rest of it? I think I'm good, but
Yeah, I'm good too. At first I did, but then
yeah.
I just found the right equation. So.
I had a problem with the applet. I don't know, do you have to like refresh it or download it again or something? Because I would put in the percentage and then it would not, and I highlight it and it would disappear, it won't like cooperate. I don't know.
Yeah, that's weird. I haven't had that problem, but maybe you do need to like I don't know. I think it's just like a website, isn't it? Kind of. Like it kind of looks like it's just a website.
And did you get an email that you have to like renew your membership or subscription to the SPSS?
I got the free one though.
No, I had to pay for mine in order to use it. So, okay.
I'm trying to like not eat in your guys' ears. I need to figure out how to mute this. I haven't had like a real dinner.
Yeah, so you're okay.
Well, it's like the microphone's right there. So.
Yeah. But hey, at least you're not the only one eating.
Okay.
So. Where's what?
Okay, and then I have another, maybe a dumb question, but for 11, it says to create the 90% confidence interval for the original 50 students. I did that, but my numbers are like slightly off, and I've calculated it over and over again, and I can't get exactly the numbers that they said they did. Like it's off like one number, and I rounded it and doesn't, I don't know, jive.
I gotta pull up what the thing says and check mine. And I don't think I really paid attention.
And that will make all the difference of getting it right and wrong if you're one off a number, you know. So.
Yeah.
What was the equation that you used?
It was the x plus or minus z times the sigma over square root of n.
Okay, perfect. So what did you?
I'm sorry. Go ahead.
What did you get for x?
For x, 541.
Okay. And then what did you get for the z?
1.65.
Okay, yeah.
I used 1.645.
Maybe that's a difference.
Because I just used like the extra number that they had.
Oh, yeah, that's what I did too.
Then that's probably it then, because I couldn't get the numbers that they were getting, but I was using 1.65. What did you use? You used 1.645?
645, yeah. So, yeah, don't round it too early, I guess.
Yeah, maybe that's it. Okay, let me do it one more time here then.
Okay.
Trying to figure out what am I doing wrong.
Elena?
Yes. Sorry.
Well, that's okay. I just if well at least we can hear each other. That's the good part.
Yeah, so this weekend I dropped my laptop
Oh.
and well, it already kind of been broken, so my parents sent my sister's and I just got it yesterday, but I first used it today. And I've been having problems with the internet and like figuring it out. It's super slow and it's really frustrating.
But
Well, I'm sorry about that.
No, it's
Um,
okay. I'm trying to figure it out, but yeah.
yeah, at least we can hear each other. That's the important part.
That's
Yeah.
mhm.
Having those problems too. Mine was internet connection though.
Mhm.
Yeah, I think that made a difference. So did you get for 11, 533.55 and 548.44?
yep.
Okay, that's why I wasn't getting it. Oh, okay. I think I have to download the applet again because it's just not cooperating.
Oh, okay.
Mm.
I
So
can't
what's
remember.
everyone eating? Ice cream? Oranges? What's going on over there?
Yeah. So my
I'm
wife and I, we've been eating really healthy lately, and then today we both didn't eat so well at work. We just had treats. And so just to top the night off, we went and got a Dairy Queen Blizzard.
You're going for broke tonight, huh?
Yeah. But it's delicious.
Did you have a blizzard? You having a blizzard?
Which
Instead of
kind is
blizzard?
it?
Yeah.
Yeah. Very
Which
nice.
What?
kind?
Oh, it's cookie dough.
Oh, nice.
Ah.
I like yeah.
My favorite because it has big chunks of cookie dough.
Yeah. We have my parents got ice cream the other day, and it's not the one I usually get, which is like the cookies and cream or something. So it's like an ice cream sandwich all mixed in. But
Mm-hmm.
yeah, I'm talking about.
Uh-huh.
Yeah, but they got a cookie dough one this time, but they're little tiny like yogurt cookie doughs in a bunch of vanilla ice cream. I wish they were big
That
chunks.
sounds
I'm so
good.
sad.
That sounds yummy. Alrighty. Well, should we do number 12?
Yes, please.
Good.
Okay. So it says, how does the margin of error for the 95% confidence interval that you computed in question 8 compare to the margin of error for the 90% confidence interval that you computed in number 11? Um, um, so, so do you see the difference between the answers for number 8 and number 11?
Um, Number 8 and 11.
I feel like this part would always kind of like you have to look at it really closely because it depends on which one you're looking at, or which value you're looking at, which direction it goes on the number line. Does that make sense?
Well, the only difference is the percentage of the confidence interval. I mean, it's the same sample size. So therefore, when the confidence interval is smaller, the numbers get smaller or bigger.
Um,
So I understood it as like as the percent for the confidence interval increases, the margin of error also increases.
I think that's right, but I think with this one, I think it does. I don't know how to say it. Like your confidence interval. No, that increases. I don't know. I was looking at because it changes from on one uh, number, I guess. One value goes from 549 to 548, so it goes closer to the mean. And on the other end, it goes from 532 to 533, which is also closer to the mean because it's on the other side. And so it narrows that confidence interval.
Mm-hmm.
So I don't know if that increases it, but it does narrow it down.
Yeah. Yeah, that's how I kind of understood it too.
But only on the second value, and the other one, it kind of does the opposite.
Yeah, you want them to do the opposite because they're on each side of the mean.
Okay. And I need to pause and walk away for a moment. Hold on, I'll be right back.
Okay. So are you guys doing anything fun on President's Day?
Homework.
That's so fun.
always fun.
Okay. So you want okay, Victoria, you said you want this to be opposite. You want both sides of it to be opposite? Because
Yeah. Cause, well, you know how you're adding your margin of error on one, and you're subtracting it from the other. So, trying to think how to explain this.
Well, just because of that order of operation, one's going to be one less, or it's going to be less, and one's going to be greater, right?
Mm-hmm. Yep.
Yeah.
Okay. I don't know if I can still explain that intelligently, though. Number 13. The BYUI professor would like to repeat this experiment, but he wants to make sure he has enough students in his sample to ensure that his margin error is 5. How many students will need to be in the sample to ensure he has a level of assurance for a 95% confidence interval? So it's basically leaving the variable open in a solving for that variable, right? In an equation.
Yeah. They actually gave
Okay.
you an equation on one of them, and it is just doing the same thing, but.
Yeah, what was that equation? Let's see.
I have n equals
2 over sigma divided by n. That one?
I think
No?
so. I have,
Yeah,
wait,
that's the margin of error one, yes.
yeah, so your margin of error is the sigma over the square root of n. But to find n, there's a n equals the z-score times the sigma over the margin of error.
Okay.
That,
There's a pre-step before getting to this step in order to have the n, is what you're saying?
what we're trying to look for is n.
Okay.
Right,
So,
because it
how
says
many students in the sample to ensure the level of percent? Okay.
it needs how many students does
Is
he
that
need in this sample?
in the equation, is that a 2 or a z? M equals 2 or z?
That's a Z.
Z.
That's a z, it's not a 2. Okay.
Do your 2's look like Z's too?
Yeah.
That was
It's like, did I
redundant.
make
Also,
C?
that might
Okay.
be it too.
Alrighty. So we can go back to the original information.
So you know um, your margin of error is 5, so
Yeah, so
you're
it'll be 5 equals, someone says Z squared for a 95% interval. So it'll be 9 equals 1.645.
it would be
Yeah.
9.6.
Pardon me?
I think 1.96 is for the 95%.
Oh, where did I get that from? Oh, okay.
You did the 90%.
Yeah, oh, I was looking at my
Yeah.
wrong note there. Okay. 1.96 and then 32 over the square root of n, right? We don't know what the we were solving for the sample size, right?
Yeah. And then they actually give you, you know how you just go through order of operations to find n, but they actually give you an equation too. So it's the same thing, but it's all in an equation.
Oh, maybe I should look at that. Let's see.
I think it's, I can't remember where it is in the book.
Oh, n equals z times sigma over m squared?
Yep.
Yep.
Okay.
And then you can just plug it right in.
Okay.
And then you don't have to think as much, which is the exact opposite
I
of what they
can sure
want you
use
to do.
that. Okay. Let's see. N equals, I could just work this out if you don't mind. Sorry. 32 and 5.
Oh, I just realized why I was having a hard time explaining number 12.
Okay.
We were talking about the confidence level increases, and so the interval increases. And I was just looking, the confidence area in 11 it decreases. So your confidence interval decreases, or it narrows. Which is like what I was saying. But I was, for some reason in my head, it was still increasing, and so then I was like, I'm confused. Anyway.
Oh, because it's from 95% to 90%.
Mm-hmm.
Same. Okay.
Yeah, they're, what do you call it, directly proportional. So they do the same thing.
Uh-huh. Oh, that's why I didn't get that. You have to square it. Hello. 157.3. Okay. Alrighty. Alright, I did them all then.
Did you get 158?
157.3.
So, but because it's a sample size,
Mm-hmm.
they round it up.
Round it up. Okay.
Because, like, if you're having well, they're students, they're people. You can't have, like, half of a person.
Can't have 157.3 students.
Yeah, so to have, like, the margin of error to be right, they have to round it up.
Sure.
To get it enough to have that.
Got it. I see. All right.
Yeah.
Solution. Okay. Hey, you got a haircut.
I did. Yeah. Yeah, it's really short now, but that's okay. It grows back.
Yeah.
Oh, perfect. Well, are you guys ready for the quiz then?
Sure.
Mom, don't fail the quiz.
Okay, thank you. That's my son. Don't fail this quiz.
Oh.
Weird.
That's funny. Yeah, we're gonna. Okay.
Let me open it up. Hold on.
I moved my computer close.
Okay. Hey, it's only 12 questions. Awesome.
Well, that could be good or bad.
Yeah. That's true.
We're gonna make it a good thing.
Okay.
We got this.
Group it's better.
Oh,
Trying to figure out how I can get both screens up at the same time.
yeah.
What's that done?
What done it?
Those pictures are so funny. If you look at that hashtag,
What? What
what
done
diet? That hashtag, what diet? Because people just.
it? It's funny.
For a second, it like went really quiet, and I was like, so quiet. I don't know what's in front. I don't know what's going on.
I'm just answering the questions. First two. All right. Let's make the notes here. All right, number 3. I'll find the margin of error for a 90% confidence interval when the standard deviation is sigma equals 50 and n equals 25. Okay.
Okay, so isn't that the equation? Isn't that the equation z equals
X.
z times square root of n?
Yeah, so I have m equals z star times sigma over square root of n.
Okay, yeah, that's what I have too.
Okay. Yeah, so we just do the.
So the z, we just plug that into the, or we just plug 90% into the probability applet, right?
Yeah.
And we shade it in the middle, correct?
Yeah.
What? I'm sorry. What equation are you using?
M equals the z star times the sigma over the square root of n.
Sigma. Oh, okay.
And the z star just means it's the chosen, like you did the interval on purpose.
Okay.
Yeah. I think, what do I have here? It's like it's chosen. It's the chosen one.
So first thing you do, it's a chosen one. The first thing that you do is find the 90% confidence interval, which we already know because of other problems. So it's 1.65, right?
I think we should use the 1.645.
Oh, yeah. That's right. I did have that problem. Thank you.
And then, yeah,
And
and then just times
sigma
it
is
by what
50,
half.
25.
Victoria, what'd you get for number 3?
16.45.
Okay, cool. That's what I got. But our teacher does say to go to 3 decimal places, so we just do 450.
Yeah.
You're going 16.450?
Yeah, just because it says to do
Okay.
to 3 decimal places.
Okay. Whoa. All these symbols. Okay. Number 4.
Number 4 says, which of the following statements is true? So U is a point estimator of x. Sigma is an interval estimator of sigma squared. X is a point estimator of U. Sigma squared is an interval estimator of x. I
So,
put A. Is that right, or is that totally wrong?
I think that's like the like opposite.
Oh, okay.
Actually, I think it's the third one.
Oh,
The
okay.
X is a point estimator of U, because the point estimator is like your statistic.
Yeah. Okay, cool. That makes
So
Thinking
your
it was the
X,
last one. Sigma squared, but we haven't done anything sigma squared, so I guess that would be right.
sense. Yeah, that one just kind of.
because your X is your mean, your sample mean, but your U is your population mean.
Oh, that's right. That makes so much sense then. Yeah, that makes sense.
And so then your point estimators are your statistics, which are like the sample numbers.
Okay. Sorry, I'm moving a lot right now. I have a lot of sugar in me.
Yeah. Both of you guys are silly tonight.
Yeah.
Okay.
Me?
Yeah, I'm more giggly tonight. It's good to be around giggly people. It's a good thing.
Okay.
It's true. We have lots of fun.
Good.
So
All right. Number 5.
lower limits of this confidence interval. The lower limits, that's just like the minus part of it, like the plus or minus, but it's the minus part, right?
Yeah, yeah, that makes sense to me.
Okay, so then isn't that equation,
I think that's your X minus your margin of error, so your X minus Z times sigma over square root of n.
okay.
Right, so they give us
So then
all of those. Yeah.
So x is the 0.9 no.
So
Oh,
X
it's
would be
hello.
the
Five.
what they give you.
Yeah.
And
And then
526.
95% is
okay. Let's see. Did you get 498.315?
No, but I'm doing it again because I think I might have done it wrong.
Oh, okay.
I'm still calculating. I got 498.31. Yeah.
Yeah, that's what I got. First time I did it, I got like 1200. I was like, what?
So just be sure to make it out to 3 decimal places. So for the lower one, the lower limit, it's 3.
315, right?
Yeah, that's what I got.
498.315, but the whole number, the whole thing.
Yeah.
Yeah, that's what I got. Yeah.
Okay.
Oh, so the next one's just the upper limit,
Yeah.
which is like the same thing, just adding it.
Right. So 5685.
I got 553.
Huh?
Okay. I got 553.685.
That's what I got too.
Okay.
Okay. Number 7. Are you there,
Yeah.
Walker? Okay.
Yeah. Number 7. What would happen to the width of the confidence interval if Gina increased the sample size? Wouldn't that increase it?
I think it's going to decrease it because
The
your
width?
sample size is on the bottom of the denominator. It's the denominator.
That makes sense.
Okay.
Yeah, that's because if there's a bigger number on the bottom, it's going to make it smaller.
Yeah. I think what I was thinking was
Basic rule of math, huh?
Yeah. Well, I think there is one that says there's like a section that's like factors affecting width, and I think it says that too.
Yeah.
Like if it's increased sample size, it's like a decreased margin of error, which means a decreased confidence width, I guess, or width of the confidence interval.
The decrease. Okay.
Yeah.
And that's just because the sample size thing is on the denominator. Okay.
Yeah. And then number 8, what would happen to the width of the confidence interval, a 99% confidence interval? That's the one I was thinking of. That would increase it, right?
Yeah. So, yeah, because that's just like the one we were talking about before, where they both decreased.
Yeah.
Mhm.
They both increase.
Okay. Number 9, Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours, 25% confidence interval with a margin of error of 50 hours. What sample size do they need? Okay. Okay, so that's just like the very last one that we did, right?
Yeah.
For the number 13. That's
Yeah, so you'd use that, the n equals one.
Z times the sigma over square root of n.
Yeah. So,
Well, I guess we could do n equals z times the sigma over m, and all of that is squared, correct?
yeah, everything's squared.
Okay.
Oh.
So 246?
246?
What was that? Yeah, that's what I
240?
got.
Yeah. Is the sample size?
Yeah,
Yeah.
that's what I got too.
Okay.
That's perfect. And then number 11, what is the upper limit of this 95% confidence interval? So that's just pretty much what we were doing like just before this, right?
Yeah. So,
Just
I'm trying to
x
just go through it.
plus b times. Okay. Oh, oopsie. I put that in the wrong spot. That's why I was so confused. Okay. 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 Well, I can't tell. I'm just on the same page.
Okay, here we go.
Hey, Victoria.
Uh-huh.
What did you get for Z for number 10? Oh, that's the
I
95%.
use,
Oh, okay. Wait.
yeah, I use the
The
1.96.
Yeah. 96 times the sigma. Which is 36. 0. Which is 36. Whoa.
You have to go number 2. So I just, to the nearest whole number, I just did, oh, actually, you know what? I added instead of subtracting. Now we're supposed to figure out lower limit. Stand by.
Oh.
Yeah, mine's, I need to subtract mine too.
Okay, so for the lower limit, I have 99,000. All right.
Yeah, I got 99002.
Yeah.
Okay.
If
Yeah.
you did it the next whole, yeah.
And then number 11, I got 122998.
Yeah, that's what I got.
Yeah.
Okay, cool. Sorry, I work at a call center, and so it's a lot easier to just read out the numbers rather than like 122,998. So I've gotten in the habit of 122998.
Yeah.
That's okay. That makes it easier sometimes.
Yeah.
Okay, so we put 122998. Okay, that's
Yeah,
what I
that's
have.
cool. And then number 12. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are: sigma is known, x is normally distributed, a simple random sample is drawn from the population. All of the
All of
above.
Yeah.
I agree.
Cool. Well, perfect. Well, are we ready to submit it?
I think so.
Okay. Yahoo!
It's like a Mario and Luigi moment.
Virtual high five.
I have to bring up my screen. There. There.
All right.
I think Elena's gone already. I couldn't
Uh-oh.
see her anyway. No. Just what?
All of a sudden, I want to have a